Hello guys, welcome to our channel, The Fishing Rod. In this occasion, I would like to present you why do we use the measurements of the resistance of a single phase induction motor to select what the connections are if there is no information about what terminals are for one winding or what the others for another winding. So as you know, the idea of the channel is not just to give my proposals or to share information about tips, but also to give information about the about what is behind all these tips, what are the reasons to do those things. I hope you enjoy this video. In this case, this video is also recorded during the confinement, so I hope that you will forgive the absence of illuminations in some parts of the video. As you know, there are two versions of the channel, the Spanish one and the English one. This is the English version of the channel, and most of this video has been recorded in English, in Spanish, sorry. So it's for them. There are some translations, there are some subtitling, and there are some parts that is liable to understand. Hope you enjoy the video. We'll see. Let's face a motor like that. This is a single-phase induction motor that comes from a very old washing machine, and there is no data about it. There is no plate. We don't know which terminal is devoted to which winding, or even we don't know the speed. But maybe we have some projects to build new tools, to build machines, or even if we would like to repair an old washing machine that has the motor broken. So sometimes we have the need to know how is connected. In this case, this is a 5 terminal motor. Sometimes there are 6. In this case, we have 5. Having 5 terminals, one can be sure that we are not facing a 3-phase motor. So 3-phase motor normally have the 6 terminal for for star connection or triangle connection. In this case, we have at minimum 5 terminals because we have 2 windings for washing, 2 windings for spin, and then the common point of the windings can be separated. So then in this case we have 6 terminals. It is easier to find the connections because just with continuity is easy to know which group of 3 terminals correspond to with a tester, or maybe with just a little spark, and then when we have separated the 3 and 3 terminals, it's easy to just to test. In case of 5 terminals, the reason is that the 2 common points are joined, and there is a thermostat, a preventive thermostat that will cut the feeding in case of an over temperature. It's an easy way to protect the motor. Here one can see the thermostat. It is located at the heads of the coils where the temperature can be tested. To understand what is behind the recommendations of the procedure to find terminals based on measurements, let's see this washing machine, and if we focus on the spin speed, there are two coils. One is devoted just for running in just one direction, in this case is counterclockwise, and the other winding is just for starting. There is no improvement of torque during the working period, but small coil helps to start the motor. So if we look at the windings of the motor, if we look inside, we will see that the winding for the starting in spin is smaller than the other coils. Indeed, this is the smallest one. If we open the motor and then look into the stator, it's easy to find the spin winding because it's just a two-pole spin winding to have the most higher possible speed, that is in this case 3600 RPMs in 60 Hertz. So then it's easy to see that one of the windings is in one direction and the other windings is in another direction. Here is a view of the winding once it's been cut and open to see what is inside. Then also we can see that from the North Pole and South Pole at 90 degrees offset, there are some small coils that, as we can see, the main coils are concentric, in this case from one slot to 8th slot at 90 degrees. There are the starting of small coils. In this case it's about 1, 2, 3, 4, 5 coils for the starting functionality, and we can see that these small coils also have a small number of wires and then less copper and less length of the wires. So it's for that that the resistance of this wiring is quite lower than the other windings. Here there is a representation of the two windings over the 36 slot stator. All of we know how to calculate the resistance of a conductor based on the resistivity and the length and the surface of this conductor. So as we've seen, the length of the starting winding is lower, and also the diameter
once it is open is a little bit higher. So it's for that the resistance is the lower value of all windings. On the other hand, if we look to the windings for washing functionality, we know that they are not devoted one for starting, the other for working. So depending on the position of the capacitor, one is working as a main and the other as a starting. So then both must be equal to do the same functionality, different direction of the rotation. The two coils are equal. So then both have the same resistance. It's for that reason that as soon as we find two measurements, two values that are quite the same, then we know that we are facing the washing windings.
Entonces, la misma tablita que habéis visto
Let's
en
do
otros
the
vídeos,
same
la vamos a
that
hacer
you
aquí y
find
vamos a,
in other
y
videos,
vamos a,
that is
vamos a
to fill a
hacer
table or a list of all measurements. I think it's useful to place a table instead of a column.
y obviamente
Obviously, we should
obviamente solo
just
hay que medir
take
de la diagonal
measurements
hacia
and
arriba,
place the values from the
puesto que los
diagonal
valores inferiores
to the top.
son los mismos.
So lower
Entonces
values are exactly
tomamos
the
la
same.
medida de resistencia de 2 en 2
Let's get
y vamos
resistance
tomando medidas,
measurements
por ejemplo,
between the
entre el amarillo
cables in pairs.
y el verde 91,8 y amarillo con verde 91,8, amarillo con blanco 61,6. Verde con marrón 99,9.
Once we have all the measurements, we will look for the lowest value, in this case 9.4. This lowest value then we know is the starting coil for the spin. We don't know which one is the common, which one is the terminal. Then we look for the next pairs of measurements. We see that there is a lot of similar values, but we will select the lowest pair of values. In this case, as we can see, is the exact value of the windings for washing. Let's see in a graphical way why we should take the lowest value of the pair of resistance. If we take measurements between one terminal and the common, then the only the only value that we are measuring is just the value of the coil, of the winding. This happens between one of the winding, the washing winding, the same with the other washing winding. The value was 61.6 ohms. But any of the measurements that are taken from the same terminal to another terminal includes not only the resistance value of the washing winding, but also the resistance of the additional winding. For example, between the washing, we've seen that there was measurements of 70.4 and 70.4 between these terminals, and exactly the same with the other terminal, 99, about 100 ohms, because in this case we are measuring more than one coil. So finally, once we know that the green, yellow and brown was these terminals, we can only be sure that we're measuring from one terminal to the common terminal when the pair of values are the lowest. In this case, 61.6. But there is something curious. If the value of the resistance of washing windings is 61.6, if we sum up the two values, then the resistance between the two terminals should be 123. But amazingly, the measurement that we have taken between these two terminals is now 123, but 91.8. Something is wrong. Let's analyze in a further video what's happening, and I'm sure that you will have a big surprise.
Es el blanco y el azul es el de la bobina de arranque. Y entonces claramente el verde y el amarillo son, hemos dicho, las dos bobinas idénticas más pequeñas. Solo nos queda una, que entonces ya claramente es la de trabajo, que es esta, y entonces esta es la marrón o beige. Pues hasta aquí.